Another low-hanging fruit bit is to do with complex numbers. And basically we just have one more thing to look at, and that is, let's say you have of two numbers, and in fact if you have 10 or 100 numbers, if you take the conjugate of the numbers one by one, so say I go the conjugate of x plus the conjugate of y, that's equal to, so I'll say sum of conjugate of two numbers is equal to the conjugate of the sum. So what that means is if I added x and y and then took the conjugate of the result. So I'll just do an example. So say I had 1 plus 3i and I added that to 4 plus I. So x is equal to 1 plus 3i, y is equal to 4 plus I. So here on the left hand side I take the conjugate, so that would be 1 minus 3i plus 4 minus I, and on the right hand side I'd add them and then take the conjugate. So if I added 1 plus 3i to 1 plus 4i, I do it term by term, so I add the real parts and get 1 plus 4 is equal to, what I'll just say it is 1 plus 4 and 3i plus I. So I've just added them, and then I take the conjugate of the whole thing. So if I add those, I end up with 5 plus 4i, the conjugate of, and then that just means that's 5 minus 4i. Now I'll check on the left hand side. So I had this, I had 1 plus 4, so I end up with 5 minus 3i minus I, that's 5 minus 4i. So that's an example of, adding two numbers, but the actual result is addition. So if I added 5 numbers or any number of complex numbers, I could take their conjugate and then add them, or add them and then take the conjugate, and you get the same answer. Not only do we have that, but we also have that the product of the conjugate of two numbers, and in fact it could be any number, so it could be 5, 10, whatever, and on the right hand side we'd have the conjugate of the product. So we'll just use the same example. So say I had 1 plus 3i, and so if x was equal to 1 plus 3i, y was equal to 4 plus I, then we'll just work out the product. So the left hand side is the product of the conjugate of the numbers, so that would be 1 minus 3i multiplied by 4 minus I. Well, 1, that's going to be 4 minus I minus 12I plus 3I squared, and I squared is minus 1. So that's going to be 1 minus 13I. So that's if I work out the product of the conjugates. That's the left hand side. And the right hand side is the conjugate of the product. So I'll do 1 plus 3I multiplied by 4 plus I, work that out, and then take its conjugate. So first multiply by 1, so I get 4 plus I, then I multiply by 3I, I get 12I plus 3I squared, where I squared is minus 1, so 4 minus 3 is 1, and I get plus 13I. So that's the product of the numbers, but the right hand side is the conjugate of the products. So I take the conjugate of 1 plus 13I, that is 1 minus 13I. So I get the same result, showing that the product of the conjugate of two numbers is equal to the conjugate of the product in this specific example. So that's all we need to cover. In fact, you could also do this for subtraction and division. So basically, if you take the conjugate before or after the operations, you get the same result.